recording. Meeting on tractor, infrastructure, MicroTractor. I just want to go over the OSC schedule just a little bit. So currently on the calendar, the first thing is still the aquaponics greenhouse. End of June, if we can manage it. For that, there's actually a missing link. We're trying to get in touch with Mark McMurdy, who's one of the seminal figures in world of aquaponics, pretty much like the father figure of that. We're trying to invite him to the workshop, but I got to follow up on that. We started an aquaponics working group at the Permaculture Voices conference. We've done some good design. We've got some decent people on a team, good strong core team on that. But we haven't moved forward on a lot of the design. We're working on developing that team and developing the design still. We still hope that the workshop will happen. It's not sure. I mean, it's pretty tight with about a month and a half left right now. That would have to come into place by like within the next week or two, if we're going to run it. That's going to be like only like 30 days till that announcement, so that's pushing it. Okay, but right now on the calendar we've got the PowerCube workshop for July 10th through the 12th. So we're looking at building 4 to 6 PowerCubes, depending on how many people sign up for that workshop. And that's pretty much the structural PowerCube that can be used as a structural part of a tractor, such that on July 13th through the 15th we're building a MicroTractor, which would be essentially the PowerCube with tracks and a loader for an immediate application of the PowerCube that can be pretty potentially powerful. And right after that, July 16, 17. Right now we're talking to Dan Hartman from Dan's workshop. If you Google that online, let's see. Let me just Google that. dansworkshop.com. Put that in the calendar and the hangout there. If you look at that, scroll down a bit, and he's got, in the third blog post, he's got the charcoal powered car. So what we're going to do is the charcoal powered MicroTractor. And currently we're looking at a pancake design of the charcoal. Instead of having a big drum that's kind of unwieldy, do a flat design of an 8-inch thick by 3 foot by 3 foot kind of a pancake, which can strap right onto the back of a PowerCube and have about 4 gasoline gallon equivalent of charcoal storage in that. So that would make it a, from just an experimental design of a gasifier to something that could really be used in practice, because that's going to give you about 4 hours of runtime for the MicroTrack, which is just perfect. And the form factor of it is such that you can actually use it. It's not something dangling from the tip of your tractor or something like that. It's compact and tightly fit. Okay, so that's we're aiming to put that workshop on within the next week. We're kind of going through the design, basically scoping this whole design, how we want to do that. After that, we've got so July. Let's see. We got the Gasifier workshop. I just covered that. July 18th through the 22nd on the calendar, we've got an open source GIS and /site design workshop. So we've got a person from OSGeo. Let me just put that up here. OSGeo Live. If you haven't seen this is the link here. Basically, open source GIS, geographical information systems, applied to a thorough process of how you go from zero to a finished site plan, basically like a permaculture site design, with all the layers on a map that's cloud shareable in professionally packaged GIS software. And the good part is it's open source. We're also considering one guy from the OpenStreetMap project, where with aerial drones you can take pictures from 2 sides and get very accurate, like 2-inch topography maps of a site. So that's in the works right now. We'll see if we get that guy, but we definitely have the guy from OSGeo Live available for this workshop, and we're trying to put that on the calendar within the next so everything, absolutely everything, is on the calendar by the 1st of June. So moving forward, August 15th through the 24th, that's going to be our big Summer of Power, the big tractor build event where we build a tractor for Scott. That's going to be a workshop. We're looking at building both the backhoe and the bulldozer at that time. And the results will really depend on how many people show up. I would say that if more than 24 people show up, then if we can get more than 24 people, then we can definitely build those three things. Our track record on the tractor right now is the last time we built it in 5 days. It was very inefficient at that time. It was pretty much like wasn't an extreme production run. It was pretty much an experimental production run. We can definitely do that in a more streamlined way if we get the design in place in advance, which we're working on right now. For the backhoe, we have a prototype that we've done before. There's some mistakes in it that we got to correct. We can do that. And then a bulldozer. So we're talking about a 30 to 36,000 pound machine with 6 PowerCubes. So we're talking about pretty much testing the limits of whether the GVCS, as it is, using the existing components, can build the world's biggest machines. So this is really pushing the testing the modularity aspect and scalability aspects of the set to max it out and see if we can do that. If we're successful in that, we're going to use both the bulldozer and the ripper on this bulldozer in the September 12th through the 19th workshop, which will be with Mark Shepard of Restoration Agriculture. And that's intended to be a site design workshop where we actually do some of the earthworks for erosion control and ponds and earthworks and waterworks. So that's a summary of the plan.
If you don't mind, let me interrupt for just 1 second. I'm curious about that, the Mark Shepard, and you were saying the ripper. What exactly is a ripper?
Keyline plow. That's the permaculture word.
Okay, because I have a dual bottom plow that I use to rip some swales, and I noticed in that Mark Shepard video that I shared earlier, he was using the front blade of a bulldozer to rip a 1/4 mile long swale. And they said that he initially started out with a Cat D4, I think, and they said that was not sufficient, and they had to upgrade to like a Cat D7 or something like that.
Right.
A heavier duty, and then it was able to do the work they needed.
That's right. We're looking at a Cat.
That's in that link that I shared a while ago.
Okay, can you share that link again, because my computer crashed.
Okay. Well, I will share it on the side over there. And this was Mark Shepard doing it.
Yep, that's correct. You need the word on the street is you need a D6 or higher equivalent to do the proper work in one pass. And that's what we're aiming for. So 6 PowerCubes, 150 horsepower, plus a lot of dead weight in the form of concrete slabs. Just basically PowerCubes are pretty much filled with concrete dead weight, like basically cubic, basically fill in the empty space with concrete, which is cheaper than steel if you want to get dead weight. Okay, so that's cool on that. Okay, so with that said, Scott, tell us a little bit more about I don't know, anything related to your needs on the tractor, and just for the record. So you're looking at a tractor that you can use down in Belize that will get you what kind of functions, and specifically are you looking for down there?
Yeah, Martin, I think first the tractor will probably head out to Ron's ranch. He just finished his 5-year master plan with a few other permaculture goals. Might live out there for at least 6 months, be put to work out there.
Okay.
It may even actually just bypass Belize. We might ship it straight to Costa Rica to do development on the 148-acre property. But that is pretty much virgin land. I mean, a lot of it's old growth that we won't be touching, but we have about 40 acres for permaculture design center space and wolf farm, and just compared to what you guys are doing in Missouri.
Okay. Yeah. Now so if the date right now the proposed date is August 15th through the 24th. You can make that? You'd be able to make that, or?
Yeah, I'm pretty sure I can, and I will try to get a hold of Ron tonight or tomorrow to confirm that that works for him.
Okay.
And then even if he's not available to come, if those are the dates that work best for you, then I can pretty much commit to those right now.
Yeah, that's pretty much determined. Like right after that, there's actually so we're going. Katerina and I are going to we have a Ted Fellows retreat on the 26th, which is in California. So we gotta do that. And when we get back, we're gonna do. I didn't mention in the schedule, but upon coming back early September, September 5th weekend is gonna be the Afforestt workshop. So let me put a link to that. Afforestt. Here's the link for everybody's reference on that.
The tractor that we'll be building in August, will that have a Yeoman's plow or keyline plow?
I mean, this one, I mean, the tractor itself is just a tractor with a loader bucket, so no. I think we should put a, pretty much like a PTO. So we're looking at learning from the tractors before, where we had the PowerCubes dangling off the back. Right now, because they are structural, we're looking at putting on a 3-point hitch on that, upon which you can hang all your implements, whatever you got. We can talk about, I actually would like to build the keyline plow. When I was looking at the Global Village construction set, we have the, you guys there? Oops. Let's see if we can reconnect. Are you guys there?
I think he's back. He's probably going to have to restart his recording.
Okay. No, the recording's still going on.
Okay.
Can you guys hear me?
Yeah, we lost you. You totally dropped out for a while.
Okay. Some bad connection here. So anyway, how far did you hear? Did you hear the structural PowerCubes on the back are the new thing for the future iterations of all life tracks? Like the Life Track 4, we had the non-structural PowerCube in the back, which made it very hard for any implements to be put on the back because the PowerCubes are in the way. So with a structural PowerCube, we can hang whatever additions that are supposed to be behind the tractor with structural strength. So we can put a 3-point hitch, whatever kind of an implement mount that will hang onto the structural PowerCube, where the PowerCube, like in the heavier version, like for the Bulldozer, it will be 1/2-inch steel for now. Like this, the smaller tractors, like up to 54 horsepower, you probably want to just use 1/4-inch steel for the tubing. For bigger than that, like once we go to the monster machines, we want to use the 1/2-inch steel wall tubing. Still the same 4x4 profile, except the wall thickness on the metal is 1/2-inch instead of a 1/4-inch. So Scott, it would be great to get the keyline plow in that weekend workshop. So that means the schedule on my side here is to put up all the workshops by June 1st, and from June 1st pretty much focus on making sure all the design's in place. Tom's got the PowerCube pretty much under control. We're working on the MicroTrack for the scaling of up to any bigger machine up from the MicroTrack. That means you can pretty much put PowerCubes back to back or with an articulated joint in between them, but basically think of just bolting them together. If the structural strength is not sufficient, we can put additional 4x4 tubing members to connect the PowerCubes. But as is, the idea was that you can connect at least 2 PowerCubes to one another to retain a structural unit that you can put everything else onto. But for the the big workshop in August 15, the idea is to experiment a bit with what are the limits to the stackability of the PowerCubes. As far as the keyline plow, we should definitely put that into the August 15. I mean, if you're into, I don't know how relevant that is for the site that you have, but I mean, if I know for us it's quite relevant to get the fertility, to do keyline plowing, to get the moisture penetration into the soil, and to get all the microbes stirred up and going down into the keyline furrows. The concept is basically you dig with the keyline so that the soil starts forming from where the keyline plow went, like, because then you allow water, microbes. You can perhaps like put biochar down there, just basically like maybe keyline plow through like biochar so that biochar falls down there, but basically you're starting to get the fertility happening, the biological life happening a few feet down under the earth, so the earth rebuilds itself. So that's critical for us, what we want to do here. It will be good to.
I know Costa Rica, we're going to be making a lot of biochar with the deadfall there on the oven that one of the other partners is developing. So like I said, I'll try to talk to Ron in the next 24, 48 hours and send you a list of all the attachments that we would hope to be able to acquire or build.
Yeah. Okay. If it's I mean, so if we got that 10-day build, there's only so much we can do, but hopefully things like right now, keyline and backhoe and bucket, yes, absolutely. The 3-point hitch on the back, that has to be done, because I mean we can't put implements on the back otherwise. So yeah, then we can talk about what other things can be managed in that time. Yeah. So tell me, on the Costa Rica land, is it treed up right now? Is it like former ag fields, or it's like just raw land? I mean, just afforested land. Scott, did you get
leaning out there a little bit?
Okay, sorry. So on the
Sorry, I was having a hearing you, but the gist of your question is what is the land?
Yeah.
148 acres. I would say maybe half of it is old growth forest. Is, like I said, right outside of Corcovado National Park. The gentleman that we acquired the land from, he and his wife lived on it for about 30 years, kind of small scale farmers. Someone's actually down there right now doing a bunch of soil sampling for us. You know, he's been monocropping there, so we might have to let him rest and develop new ones. But I think some of the area, or at least probably 20 acres, would be secondary growth forest to develop. But it's not particularly rocky or hard soil. It's soft. I mean, it's the southern part of Costa Rica gets a fair amount of rain, certainly during the rainy season as well. But I can have the guy that's down there right now try to send me some more information on the soil to get to you.
Yeah. So things like, I mean, is that land like pretty? I mean, just like anywhere. I mean, is it eroded, or is it like, so you would want to do the keyline plowing for fertility building and all of that? Or, I mean, I have no idea what it looks like down there. Yeah. I mean, you definitely want the keyline plow to be one of the implements at that time? I keep cutting out here. No, I asked if the keyline plow, so you definitely want that to be one of the implements.
Oh, I'm sorry, I didn't quite hear that.
Yes, so keyline plow would definitely be one implement that you're interested in.
Oh yeah.
Yep. So for sure for us, because I mean, I think for our work here, like the single most implement for like reworking the soil right now is the keyline plow for us. I kind of thought it would be like a spader for preparing soil, but since we're gonna focus a lot on the perennial polycultures, alley intercropping, then there's not a lot of case for tilling as much as there is for like rebuilding the earth through things like keyline plowing. So anyway, that's the new learnings from this year. Okay. All right. Anyway, so that's good stuff. Let's see, Tom. Can you fill us in on the latest on the PowerCube? Like, what's the real challenge? And to summarize basically the pump issue, which we have issues on sourcing the pump. Yeah.
Okay, the pump, we've gone around and around about it, but I think, you know, in my survey that I've done, I don't think we're going to be able to hold on to that 3/4 inch shaft. Because the only other pump that I've seen that has a 3/4 inch 11 tooth spline shaft is Cessna, and it's a very low RPM.
Yeah. So what's the deal? How come? So did you kind of like look at that exhaustively? Like, just no one makes these kinds of pumps in 3/4 inch splined?
I think that, you know, this is just my presumption, but I think that the 3/4 inch is large for that displacement of a pump.
Mm-hmm.
And say if you want to, usually you have larger shafts, but they're usually related to higher displacement pumps.
Mm-hmm.
And so that's why most everybody goes to the 5/8. And the 5/8, it's only 1/8 inch less than the 3/4.
Yeah.
So I'm thinking that we should really
Just
probably give that a go.
Okay.
And you had mentioned that some of the 5/8 inch spline shafts had been destroyed. I mean, is that the actual shaft itself had been destroyed, or the
No.
pump itself?
No, I mean, the idea was that all those pumps, I mean, they ended up, the persistent issue there was that we ended up like with pump leaks. And what's the reason? I mean, was it that the hydraulic fluid was dirty or whatever, or shaft was misaligned? I mean, I don't know, but we just know that it hasn't really worked well until we never had a failure of the 3/4 spline shaft yet, the pump with that.
Well, that I'm thinking is something that we could probably control, and I think a lot of it probably had to do with the shaft misalignment.
Yeah.
And with the current setup, the way we're doing it, it's been really good. And I think if we apply a little bit more tolerance checking to it to make sure we have tighter tolerances on the parallel plates between the pump and the engine, that's real big. Parallel plates and the shaft coupling. If we make sure that those are very, very precisely done, then I think the rest of it will just fall in place.
Okay. Yeah, we got to try it. Yeah, I mean, that's pretty much our only option. So use a splined 5/8 inch pump.
Yeah, but the cool thing is that when we do go to the 5/8 inch, we have a lot of options. We have dynamic and currents, and we have a lot of choices to choose from.
Okay. Well, let's just...
So that really opens up a lot, and it gives us a lot of fallback. Whereas for the 3/4 inch, we don't. I mean, I can't even find a single source of it right now, much less 3 alternate sources.
Yeah. Okay. Yeah, let's do it. Let's do it. Okay.
Now we'll have to have another jig. I have one jig for welding that spline, you know, the shaft coupling. But we'll have to come up with another one, or maybe just take the one I have and tool it down a little bit to the 5/8 inch shaft instead.
Okay. Okay, that sounds good. So, with respect to the latest CAD, is that up online? Are you done with it yet, or are you still working on things?
Well, funny you should mention that. I tell you what, let me give you a screen share and I'll show you what I've been doing.
Okay.
I was working on yesterday and also today.
Nice. Yeah.
And are you seeing it?
There we go.
All right. Well, this is what I have now. You can see all kind of parts flying around to the sides because it's all the stuff I've been dealing with. You know, trying one part and trying another. But this right here is what I have for the output, and you can see I have 2 1-inch output hose barbs, so we can.
Whoa! That's the output of that's the return line.
This is a suction
suction line. Okay, yeah.
You see, we got the 2 with the yellow handles.
Yeah.
These are coming out of the suction strainer out of the hydraulic reservoir.
Yeah.
And then this is, you can see the one other line, it lines directly up with the pump. So
okay.
That will be our input to the pump.
How is that connected? Through a hose?
That'll be a rubber hose going between these two. Because I had to do that to stand it off a little bit so we can get some more distance. because
Yeah.
those rubber hoses, they need a little bit of room in between one and the other to,
Oh,
in
wow.
order to flex and
Okay.
to not have vibration.
Yeah. No, this looks pretty exciting. I can see how, I mean, that is like way simpler. I think that's a major piece of progress there, right?
I like it.
Yeah,
And
I
then
think it's good.
also on the other
Yeah.
side over here, I reworked the where the oil filter and all that goes.
Mm-hmm.
And right now, I moved it up over here, and so all we're going to have attached to the tank is going to be just the one little swivel. Now, also, I was looking at the hoses that we were using, and it was those JIC fitted 3,000 psi hoses, which is way overkill for return line plumbing.
Mm-hmm.
So with that in mind, I said, all right, well, we need to go with these swivels, and we can go with a little bit less rigid hoses, something that's a little bit more flexible, that'll give us shorter bend radiuses and that kind of business. And then I looked at it, and I decided, well, we can move the filter away from the tank and just move it up like this. And so the way I've got it right now is so that it's on a little bracket over here together with the ports for the
Oh, okay. Okay.
the pilot valve and case drain return will go right here, and this would be the return.
Okay.
And then these again are going to use the standard NPT fittings rather than the JICs.
Mm-hmm.
And anyway, I'm still working that out as far as the plumbing for that, but I'm liking the way this is coming together.
Okay. And then the outlet of the pump, you just have the quick coupler right on the pump?
No, this is it right here, because the reason we can't have the quick coupler on the pump is because it has to connect up to the pressure relief valve.
Yeah. Okay.
And this is what I'm showing right here.
Okay.
And so what we'll do is from the front side of the PowerCube. Oh, I got lots of junk flying around here.
Mm-hmm.
But so here's the output of the pump right there.
Yeah.
And then here is the input to the pressure relief valve right there. So we'll just have a little hose that goes straight from here to there.
Okay.
And this will need to be the JIC hose, because those other hoses, return line hoses, they're not rated for that kind of pressure. They stop at about 2,250 psi, and so we need this to be 3,000 psi compliant.
Mm-hmm. Mm-hmm.
So at any rate, we'll just have a hose go directly up here to this one, and then this is going to have a return right over here that'll go back over to the oil filter. It'll couple with the oil filter right there, and so that'll be for our pressure relief overflow. When we have overpressure, it'll just drain directly. And I put it in front of the oil filter because I want it to be filtered before it goes to tank. Because just in the case this pressure relief valve decides to come apart, I want the filter to catch the fragments. Because these pressure relief valves, essentially what we're saying is that this valve, in the case of overpressure, it will basically, how do you say it? It'll dissipate all the power that this extra that would have been delivered at that overpressure.
Sure.
And so what that means is this thing is going to get very hot very quickly. So these things have to be kind of expendable, and that's also why I wanted it bolted to the frame so that we can dissipate
expendable. Heat. I mean, they're designed to be reusable. I mean, that should be living forever, right? A lifetime should be high for that. I mean, it's not designed to fail when it bypasses. I mean, in fact, the bypass condition can be frequent.
It's not a one-time thing. I mean, this is a highly reliable pressure relief valve, and this is the more heavy duty of the valves that they have.
Mm-hmm.
But I've heard that when people they've used these in test setups in order to test other equipment, and when they do like we were talking about brake testing and all that, they say that these things totally fry. They'll start rusting. They'll overheat, and if there's any seals in there, then the seals will come all apart because it gets very hot. Because even in this case, like we have here, it'll have to dissipate up to 28 horsepower in a single little metal block like that, and then that'll get it really hot very quickly. So we just have to be aware of that and be ready to. I mean, in normal operation, you'll never fry one of these. It'll never happen. But it's only in exceptional circumstances.
Yeah.
When you're doing, if you have like a brake test setup, or you have some sort of say you, in your bulldozer you have it to where it's going downhill and you have to do regenerative braking and all the power gets dissipated in that one unit right there. I mean, something really weird and unusual.
Yeah.
So anyway, I did that.
Yeah.
And then also, like last time, I was beginning to put like the control panels over here, and the control panel for the PowerCube. I mean, all it is a key switch and a throttle, so that's pretty straightforward. But Jean had drawn up a control panel for the life track or the MicroTrack, and it looked really good. So I figured it, well, with this, maybe we can integrate it along with that. Maybe bolt it a little bit to the side, and this is flexible. We can move it around, and then we can bolt the other controls in front of it.
Yeah. It's looking good.
So that's pretty much where I am right now. Now, one thing I did want to catch up with you on is the plumbing. You see this one right here. We do have this extension where it comes out of the center of this tank and it goes directly up, and it has a valve on top. Is that right? You wanted a valve?
Yeah. The valve is not even necessary, is it? I mean, we don't really need the valve there. It's just a filler.
Right. I wouldn't think so.
Do we need a valve there for anything?
I have one here right now.
What is its purpose?
Well, the original purpose we put it on there for was to prevent sloshing out from as it goes from side to side. But since this is in the center of the tank, you don't have that sloshing. And so also, since we extended the height of it here, we should have less overflow coming out of this port.
Yeah, I don't think we need the valve there.
We do need it?
I don't think so. I think part of the reason for that was if we wanted to stack PowerCubes vertically, didn't that have something to do with that?
I think so, yeah.
Let's see, what's the logic there? Yeah, we can always put that valve back in, or are you going to use a longer pipe if you take out the valve?
I would use a little bit longer pipe. I would raise it up so that the fill port is almost to the level of the top of the PowerCube, kind of like it is now. Just a little bit less, make sure we don't bump into anything and break anything off.
Yeah. Okay. How far is it offset from the bar, the tube, so you can get a filter in there? Like, not a filter, a funnel?
A filter?
No, a funnel, just a funnel.
We have right now, if we go all the way up to here,
funnel.
That's 1 foot, 1 3/4 inches. So it's a little bit more than a foot.
But off the tube on the top there, how far is it away?
From the top? Oh, you mean from the side over there?
Yeah, from the side. Yeah.
Let's see.
Yeah,
almost 2 inches.
Okay. Yeah, so let's see. Let's just think about the condition. Like if we're... So I don't have clarity on this, but if we're stacking PowerCubes for bulldozers, I think the best configuration is if you go to the side and to the front and back, like not vertically. Because, for example, if you have a bulldozer, you want to put a cab on top of... Like I was thinking the cab would actually be on top of the PowerCubes that are on the bottom. So you're kind of like riding in a cab that's above these PowerCubes.
Right.
In which case you're not stacking the PowerCubes vertically, just either front and back or to the side. So, but do we foresee any purposes where we want to stack them vertically? In which case we would want to close off that port there for leakage if you stack vertically.
Right. I don't see that. I mean, the other way to do it would be we could just take this port and just take the valve off and put the filler, 4 or 5 inches down lower. And then if we do need to stack it vertically, then you can add a valve to it if you need it.
Yeah, and that's a 1-inch tube. Or
It's either 1 inch or 3/4.
okay, you got to make that 1 inch definitely. So make that note because 3/4 is get you trouble filling. So definitely
Okay.
1 inch. That means you probably have to reduce for the breather cap because those typically are 3/4.
Hey,
Unless you
Martin,
get
one thing I was wondering about that, and I've heard that there's so much trouble about burping while filling and all that.
Right.
And it just occurred to me that, gee, well, has anybody tried to fill it and put like a little straw down all the way through the length of the tube while it's filling to let the air flow parallel to the fluid?
As long as that straw does not go reach down to the liquid level.
Right. That's what I'm saying. Just enough to reach the top of the tank, and then have it reach to the air on the outside, and then you can fill it. And that's just a one idea, but I'm not sure even going to a 1 inch would really resolve the burping issue.
Uh-huh. Oh yeah.
But I've seen some of those funnels. They have these filler funnels, and they'll be very long funnels, but they will have a little straw that parallels
Oh wow.
where the fluid would go. And it's just for that purpose, for breathing.
Can we just open up another hole elsewhere that we do put a little valve on for breathing while you're filling? Because that would address that issue, right?
You mean drill another hole in the tank?
Yeah, we don't want to do that. Is there any other way? Is there any other place where we can put a breather hole for filling? That's already available.
Well, yeah, I would just say maybe one time, if we can find a little straw and try that one time and just see if that helps or not. That's an easy
Right,
test.
right. Can we do
That could even be like a little straw, like you get when you get your go to get a big gulp at the store.
just a regular straw you just stick down, or how do you hang it?
Just well, if I were to do it, I would take a funnel and I'd have the funnel, put it on top of the tube, and then just put the straw down in the middle of the tunnel and have it sticking maybe 4 inches above the, where the funnel ends, and then just start pouring fluid in, and it would flow around the tube, not through it.
Yeah. Yeah. Okay.
Worst come to worst, we could develop our own OSE funnel. It'd be a long funnel that would have a little tube in parallel already.
How about a 3D
glued to the
printed
inside.
a 3D printed one? You could 3D print a funnel that would work for this.
Sounds like a plan.
Yeah. Okay. No, but I see the issue of
Just print it out of some plastic that is oil resistant.
like ABS is ABS oil resistant.
Oh, I just noticed my fan is actually embedded inside the tube frame of the PowerCube. It's no good.
Yeah. Let's see. So, as is right now, how symmetric is this? This is not. We can't make the frame itself symmetric because the tanks wouldn't fit, right?
Right. Now we could shorten the tanks. We could use smaller tanks, but that's the only way we could make it fit, I think.
Okay. Right. Okay, so let's see. Any other main questions on this?
Let's see.
So I think it's coming together.
I think that's largely
Pretty well.
it. The next thing, once I get all these geometries and the plumbing figured out, then I can go ahead and generate the hoses, and we can start getting hose lengths, and I can start generating a BOM. I was working on a battery mount for it, and that basically it was going to look like this. That basically it would be like a little two-sided mount, and we can place the battery inside the frame, kind of like. Let's see if I can do it right now. Just move the battery over a little bit, and then move it down, like move it right over here somewhere. Mm-hmm. And then we can have this little two-sided frame that would basically hold it in place.
Where's the frame attached to the outer tube member?
Let's see, I was going to move it right over here real quick.
I see.
This thing would basically come with the battery.
Oh, okay. Oh,
and I was thinking it could go like that, and then we can just lower the whole assembly, and then we could drill a hole inside this so we could bolt it to the tube like that, and there you'd have a battery mount.
Okay. And you wanted to move it down just a little bit to get out of the way a little more?
Yeah, we can put it as long as I was thinking this would be like a 2x2 angle iron, and then we could, as long as it can reach those 1-inch holes there.
Sounds good to me. Can you just show the little bit of the issues on the non-symmetry, and let's see whether we want to kill that or how much, just talk about a little bit how much that matters or not. Because
okay, here's the issue with the non-symmetry. As you look at the PowerCube from the side, you see 9 holes on this side, and it's 8 holes high on this structural steel. And so the non-symmetry part of it is, you see how this tube right here is on the inside of the cube,
right?
But the corresponding tube over here is on the outside,
right?
Same thing for the bottom. Now, as far as structural strength, I don't think it would affect the strength of the cube. The bolts holding it in there on 3 different axes for each corner, that's where you get your strength from, and that is not changing. So also you can see from this side, you can count 9 holes here. So horizontally, either direction, it's 9 holes, and then the vertical, we have 8 holes high. So we had tried to build a PowerCube, and I think we did build one, and we have a kit for another one that's an 8x8x8 cube with vertical tanks, but that was having some fuel delivery problems. So this is the design we've pretty much settled on right now, going forward.
Wait, hold on a second. Why, if you symmetrize it, in other words, put the ones on the right-hand side to the outside, the verticals to the outside, why wouldn't that work? Oh, because the engine is there?
You're right.
Oh, yeah, the back of the engine
there. You see the yellow part right there is the engine.
Yeah. Okay. Yeah. No, I think it just doesn't fit unless we shrink up the fuel tank. Is it possible to put the... Hold on a second. Is it possible to put the fuel tank in more so it's actually the distance between the 2 fuel tanks is smaller? Would that allow everything else to fit, or it doesn't allow that anymore? If you put the fuel tanks in more so that they don't go into the way of the... Wait, does that solve the issue?
Yeah,
or
fuel
no?
tank, we can bring it over kind of like this.
Yeah.
so they would be inside the 4-inch tube.
Yeah. Yeah, they don't fit, do they?
It's really, really close, and then this right here is, I don't know, it might fit. We'd have to figure out, we have to move the fuel cap a little bit, but that can be done.
Wait, does that address the symmetry issue? Or that doesn't change anything?
Basically, I tell you what, if we have this much room to play around with, I mean, this is already a 6-inch thick fuel tank, and if we have that much room to play with, I would tell you, I would opt to go with a commercial off-the-shelf fuel tank if we can.
Right, but then how do we mount the engine? So we have to redo the engine mounting?
Yeah, we could figure something out for the engine. I mean, right now we have the fuel tanks hanging from these 2-inch straps right here, so we could figure something out for the engine as well.
Right. Well, that part would be something that will drastically simplify the production of the PowerCube.
Right. The tanks are the most complex thing to build, and they're also very heavy.
Yeah.
And they're problematic building it just because they do welding those things, the plates on the end of it.
Right. No, that's.
At any rate, that's another one of those things that we might think about for the future, but I think for the July run, we're going to have to stick with this design right now.
Just do that for now. And the tanks right now are how big? They're 24 inches?
I think it's 22 inches on the side. Let me get my tape measure. We'll measure. Where's Jonathan today?
I'm online. I'm just listening. I'm out in the field working. So yesterday I worked 22 hours straight, and then I got called back in this morning. So it's been a long weekend.
You slacker. Got an extra few hours there.
Yeah, it's been a long week.
Wow.
This one's right at 22 inches or 21 and a half, something like that.
Mm-hmm.
And they hold about 7 gallons per tank, and that's both for hydraulic and for gasoline.
Mm-hmm.
This one also, you can see I took the sight gauge and I moved it up a little bit, went with just a 6-inch long sight gauge instead of the 12-inch one, because really, I mean, this will tell you everything you need to know.
Right.
If the hydraulic fluid is more than this, then you're good. If it's less than this, boy, you better add some quick.
Yeah. Yep. Yeah. Just to wrap up the fabrication question, if we're going to be building 4 or 6 of these in a workshop, how do we get the tanks made? If there's, I mean, that's not unless we have welders, skilled welders, that's going to be pretty hard. So what's the assumption there? Maybe we have like a couple of people dedicated to welding the tanks, and everyone else does prep.
I think so, and take some of your better people.
Yeah.
And also, the one thing I'm going to be testing soon enough is I want to test the fabrication techniques of, instead of using the standard bevel and standard welding techniques we had been using, I want to use that something similar to what we saw in Austin when we went over there. And that guy, what was his name? I forget. Adam or anyway, the guy had some real good tips on doing that.
Yep.
Welding those tanks, and I think we can apply those other techniques to it and weld consistent tanks with less leaks.
Yeah, techniques can be applied. The question is getting a really nice straight cut on the ends of the tanks. Because if those cuts are not straight, his techniques can't really apply them because the spacing will be different. Yeah. Anyway. I mean, we can do it. We can absolutely do it. But probably just for reference, during the workshop, there's going to have to be 2 people that have to do the tanks that we know that are skilled, and it may have to be, if nobody else has the proper skill, then it might have to be me and you. So, at the worst case, we have to be ready for that. or at least make it that we're not needed in other places for the tank welding.
Hey, I'll tell you what, Jonathan was up here working with me on some of the tanks a while back, and he had a pretty good hand on doing that.
Okay. Yeah. I mean, hopefully there's going to be people that we feel comfortable with, and that could be a good point. Like, that could be a nice, like, in the education part of the workshop, that we can basically get people experience on that, and we can see who actually can do it reliably. Yeah.
Yep.
Okay. Well, that sounds good. Sounds good to me. So that's the biggest risk for the workshop itself, for the PowerCube getting finished. That's the biggest issue there. Yeah. As far as the CNC torch tables, so the guys from Caruza, it looks like they will be testing theirs like within a couple of weeks, so we can copy their design. In which case, I would build that here, like in June, to have that available for the workshop. So that'll be good. That'll be really good. Yep. Yeah, which would remain, that would just leave the tank welding as the toughest part of the workshop. But I think we'll handle that. I think that'll be fine.
Do you remember what the max size of the steel that thing could take? Their design.
Max size of steel? It depends on the plasma cutter. The standard is piercing through 1/2 inch.
Oh, I mean the length of it.
It's scalable. It's absolutely scalable. They're doing it so you can put the structure as long or short as you like. So yeah, like 5 by 10 for us, 5 feet by 10 feet for us. Yeah.
Cool.
Yeah. All right. Well, I don't know. I think that kind of wraps up. I think we're pretty good shape on the PowerCube. That's pretty good. MicroTrack, I think, is moving forward. We're definitely moving forward on Gasifier. That's good. That should be really good. Let's see what else. Yeah. So anything else? Is that all we got to cover for now, or? Tom, you got muted.
Here we are. Yeah. The only one of what is it? Are we done with the PowerCube, or done with everything, or what?
Yeah, I mean, as far as for this meeting, are we okay to proceed then? So we'll go on the smaller shaft pumps. That was the biggest question. We can do that and make them work. Yeah.
Yeah, get a little bit more precision in the shaft alignment, and I think that'll probably solve that. The only one thing, Scott, are you still there?
Yeah, I'm here, Tom.
Yeah, the only one other thing I would like to share with you is that there's this one YouTube video I ran across. It's by these people called Eco Oasis, and video, and they're doing permaculture things in your neck of the woods down there in the Costa Rica or somewhere down there. I think they were in Puerto Rico, but basically in a tropical climate. And they had some really good tips that were just for that. So maybe that.
Is that the YouTube link you just sent?
Yeah.
Post. Cool. Well, I will certainly check that out. Thank you.
Mm-hmm. But other than that, that's all I had.
Okay. Jean, anything from you? Any other comments, or? Yeah. Yeah, I think.
Tutorial for all recordings that I did while I was working on the MicroTrack infographic tonight, and I'll post the link to. Well, I'll post the video to YouTube, and then I'll send you the link to that.
Yeah.
Right. It looks like it's 6 hours of video that needs to be edited.
Holy cow! Are you trying to put 6 hours up, or? Can you?
Yeah, I think it holds as big as 12 hours on YouTube. Okay.
6 hours, but the file size is like pretty manageable.
Well, I mean, it depends on what kind of working with. File size, I'm not so sure what will be like. I'm waiting to see what kind of running.
Something that's manageable for somebody to download. So something that's no more than a gig.
Right. I'll try and see.
See if you
yeah,
can
like
get.
I said, I'll see what comes out and
See if.
reduce if it's necessary.
Yeah, but YouTube will let you put up something that long?
Right, I've seen videos that are like, yeah, I think they're actually 12-hour long videos. I think that's the longest you can post.
Okay. That sounds good. Crazy.
Wow.
Right.
Yeah. Okay, that sounds good to me. Yeah, so you're talking about the instruction of how to actually make an infographic like that we can edit and actually.
Right, it pretty much goes into step by step.
Wow.
How I created that infographic.
Excellent, excellent. Right. Okay, okay. Well, that would be something good that we can, if we could teach people. But the missing link for anybody though is they have to have some art skills, though. I mean, without that, you can't really do it.
Right. I mean, you need some. Well, I mean, really, it's a matter of practice. You don't need that much skill, but I mean, once you start drawing, whatever it is that you're working on, you can refine the drawing every time you basically use each previous drawing as the underlay for the next drawing, and you clean it up as you go.
Oh wow, that'd be interesting.
Right. That would be the easiest way to go about it, I think.
Yeah. Okay. Well, maybe one day we'll be teaching our people how to do that. Yeah, that would be good. That would be good. Okay. Thank you. Okay, and another thing. No, I mean that's about it. That sounds good. Hey Scott, anything else? Any other comments or?
No, again, thank you for including me on this call. It's nice to talk to you guys. I'll try to get with Ron as soon as I can and confirm that he can make it. I can certainly make it in August. And yeah, if I have any more questions, I'll email you.
Definitely. Okay, guys. Well, I think that wraps it up for today. Thanks a lot. We'll be in touch. So next time, so we'll continue the Friday 5 p.m. the Sunday 5 p.m. Just to keep checking in on the MicroTrack and PowerCube and Gasifier. Yep. So till then for this team meeting. Okay. Thanks a lot, guys.
All right.
Have a good Sunday.
You too. Bye-bye.
Hey, Scott, you still there?
Yeah, I am, Tom.